Hey,
Hello,
Lorenz.
Stefan. Thanks for having me again on this wonderful meetup. And I welcome everybody in the chat right now to this presentation about UI.
I'm going to give the stage to you. Bye-bye, Lorenz.
Yes, thank you. Okay. Yeah, let's get started with UI work. Today, I want to give you a brief introduction to a UI crate I'm actively working on and just released called Bevy UI, standing for HTML UI. And yeah, it's here to solve some problems I personally have with UI in Bevy currently. So quick background check for me. I'm Lorenz, aka Lomix. I'm somewhat active on the Bevy Discord sometimes. You can find my work on GitHub or on my website or reach out to me on Twitter, whatever. And without any time wasting, let's start talking about UI. So for most of you working currently on a game in Bevy or planning to, you will eventually reach the point where you need to create an UI. And for everybody who has done so in the past, they probably know it's not that easy. Usually, it's extremely verbose to describe your UI in Rust code with Bevy UI. It's very tedious and very long to describe simple boxes and relations between boxes and put text in there. And each time you want to check if you're actually having the right result, you have to compile, get to your game state, and then check, notice, oh, damn it, not again, it's 3 pixels off, and repeat. And this becomes tedious very, very fast. And then after you finally have to manage to create something nice, you're thinking about reusing that piece of code. And so you have to refactor your enormous mess. At least that's what usually happens for me when I work with plain Bevy UI. And of course, there are ways to make it a little bit easier. But at the end, for me, the biggest killer to my personal fun is downtime. And whenever I have to wait for compilation just to check if something is 2 pixels to the right or left, that's very annoying, and it kills my curiosity quite fast. So let me introduce you my solution to that problem, and that's Bevy UI, a way to serialize Bevy UI into HTML, or better, HTML-like syntax that can be hot reloaded into a running Bevy app, and you can immediately see what happens. All the styling in Bevy UI is based on normal Bevy UI stuff. It's just snake-cased. And now let's start with a quick overview, how the plugin works and how you use it. And then we go deeper into some examples and end it all with a very complicated example how to interact with it. So Bevy UI is designed to be very, very close to Bevy UI. It does nothing out of the ordinary. It's just a thin wrapper around Bevy UI. So when you're working on the Rust side, there's nothing new. It's just Bevy UI with all its styling and all its functionality. You can hot reload at any time. That's the big selling point. And it offers you a nice way to abstract away your design, your UI design, from the actual logic, which makes it very easy to refactor. I provide a very simple API to wire up the HTML part to your actual logic. And also there are some utilities for animations, transitions, hover effects, and so on that are sometimes very annoying to do it yourself. And without any more waiting, let's get into how you set it up. It's very easy. You just add the plugin like you would with any other plugin, and you spawn an HTML node passing a handle to your template. And that's it. You just spawned a UI. The template itself is tagged as HTML in this case with the HTML extension, but it probably doesn't care about the extension. It's just for your other syntax tools you may have, your prettier formatting or your code highlighting. That's why I prefer to use HTML as the ending. It makes it quite nice to work with. Each template starts with the template tag at the top, followed by the root node, and then you can put in whatever you want. And each of the styling is added as an attribute. As mentioned earlier, they are just the Bevy styles equivalent, but in snake case. And there are a lot of, and the value part is very similar to basic CSS, like a padding, for example, can be a single value, 2 values, or 4 values. It's very easy and very short, so you can experiment very fast with it. So, and with just using this example, we spawn our Hello World box. The next step is you probably want to reuse your templates, and that's where components come in. You can register using the HTML component system parameter, register any component under a name of your choice, and then you just can use it as a normal node in your template, and it will be included. Here's the result. You just repeat the same template 4 times. And of course, to make it a little bit more convenient, there's also another plugin, the pfui autoload plugin, which allows you to add a folder inside your assets folder to be autoloaded under the file name as a component. This is incredibly useful and makes it very, very easy to quickly create components while your game is running and import them into your running state at the same time without compiling. Yes, and of course there's also error handling. It's not perfect, but if you ever type something bad, you probably get, in most cases, a very context-rich error. You can see that at the bottom. It tells you exactly what you did wrong. But I have to say it's not perfect. If you make tag errors, you're probably, they are probably not so nice. But for attributes, they are quite handy. Okay, let's start with the first example. Let's create a button that we can reuse all over our menus. We start with a simple template, but this time we start with the button node at top. This is just one-to-one a button in Bevy. So, and we're going to add a child node called a text node, and you guessed it, the text node just adds text. And this is the final result. You get a button with some text in it. Of course, it's very boring. We want to add some spice. And this is where some of my additional features come in that are a little bit outside of Bevy UI, but are very, very useful. And these are transition effects. Any attribute can be marked with a hover prefix or a press prefix or an active prefix. More on that later. And then you can add a style, and if that state is active for that button, it automatically changes into it. There's also easing and delay, as well as you can mark each node with an ID, just like you would expect in HTML. These IDs are local to your template. They don't work outside of a single template file, and they help you to reference the entity underneath to another node. For example, this text node watches the btne ID, which is the button on top. And thus, since a text node usually doesn't own an interaction component, you can still hook onto the hover interaction state of the button. And in this case, you see that the text color changes to black. Very useful indeed. Next part, properties. For everybody who has created something with any modern framework in the past, you probably know what properties are. They are the way to make your template add some values you can change when you include them. And they work very easy. You just add on top of your template these property tags, you give it a name and a default value. And in each of your attributes, you can mark them with squirrely brackets, and they will be compiled to the placeholder value or the past values. And there's also something we will talk later, events. They are in the next step. First of all, this is how your button would look now. When you include it, you can just pass these properties as simple attributes, and you are left with a beautiful menu. Okay, maybe not that beautiful, but you get it. You can change the properties, and each of them are unique, even though they are all from the same template. Next up, events. How do we hook our Bevy backend to these nice templates? And for these, we can create called binding functions. These functions are just maps to a Bevy one-shot system. So we make our templating system a string known as a one-shot system. In this case, we register under the name start game a one-shot system, and each of these one-shot systems takes the entity as the first argument. That's the important part. That's the only thing you have to you have to oblige to. The rest are just normal Bevy systems. You can query anything your world gives you. And now with this binding, yeah, you can just call it on the onPress event. And for that, we have multiple events in the system. The first one is the onSpawn event. Any node can be marked with an onSpawn event, just a simple attribute. And the onSpawn event, as the name implies, will just call a Bevy function or one-shot system when the node is fully compiled, meaning all the properties are resolved. And then there are the button events. These are unique to the button, or better to say, unique to the interaction component, the onPress, onEnter, and onExit button. These are just basic mouse interactions, and you can create a system that hooks onto them. Play a sound, for example. And finally, we have the custom event, the onChange event. This one does nothing by default. It's just for the user to create custom components or widgets that want to tell the rest of your systems that something changed. More to that later. And finally, we have one thing we can work with. These are tags. Sometimes you want to pass information that is not rendered, but is needed for your button to work. For example, you want to set a special kind of difficulty or maybe a different kind of sound, and you want to pass the asset that is played when you enter. Thus, you can just create a tag with your custom name and a value. And then in any of your Bevy systems, you can just query the tag components. Yeah, you can just query the text components, and it's just inside, it's just a hash map. You can get the difficulty and then do your match, do your things that is required from whatever you need. Now that we have the basics, let's start by creating a simple widget and make use all of these functionality to create a reusable widget. And for that, I'm going to use another plugin I happen to maintain, the Aspirite Ultra plugin. It's just a very simple plugin that lets you load Aspirite binaries. Lets you load animations and sprites, slices, or atlases directly from the Aspirite file binary without compiling them first. So first, we start with a simple Bevy one-shot system. In this case, we are going to need the tags, the commands, and asset solver. We are going to look on the tags for a special tag we call just source. And if that source tag is present and the animation tag is also present, we then simply use the functionality of the Aspirite Ultra plugin to spawn a UI animation given the path to the Aspirite file and the animation tag presented. In the template, it is very, very simple. All we have to do is pass two properties, the source and the animation. And on our first node, we add the onSpawn, which binds to the attached Aspirite one-shot system we just have seen. Together with the two tags, we want to pass the source and the animation. And these are also properties. So when we want to use it now in another API, another template, we are just going to use the Aspirite tag, the Aspirite component. I have to mention this is inside a component, so you have to register this component or add it into your components folder. And then we're just going to pass the source file. And with that, we are left with a result that looks like this. A simple button with a number and maybe a coin animation, just for the example. So that's the easy part. Now, some widgets require state. For example, a slider. When you have a slider, you of course want to know when the slider has changed. The slider, maybe you want to do something with it. For example, change your volume. And that's where the onChange event comes in. Let's build a simple slider where the HTML or the styling part is inside a template and the functionality is inside of Bevy. First, we start with the template. The template, or let's define the slider first, I guess. A slider is actually very, very simple. It's just a box, and inside that box, we have a button. The button has an absolute position, and it can move on a fixed axis, but never outside of the container it's in. So between 0 and 100% left, for example. Yeah. We attach our function we are going to discuss in the next step. We call it just the init slider on spawn effect, so on spawn function. So this one is called when everything is loaded in, and we add our button with our absolute position. On the init slider function, all we have to do is we get the entity, the container outside and the button inside, and we mark them with two components. In this case, the slider component. This one holds our state, the value, and we start at 0 because the slider starts at 0 for some reason. And then the other entity, which is our button, we mark this with the slider knob component. And this component, just out of convenience, holds inside an entity reference to its owning slider, just so it's easier to resolve and we don't have to walk up the tree each time. So this is somehow, there's some kind of relation like parent or children relation here, just very, very simplified. So the next part is how do we calculate the dragging of the slider? This is a little bit more complicated and I don't want to go into detail, but the idea is that we query all the mouse events, in this case, the mouse motion events, and we query all the sliders and all the active slider knobs, the buttons, which have an interaction. We go through them, filter all the other, first we iterate all the mouse move events, then we iterate over all slider knobs. We filter them by pressed, so we only get slider knobs that are currently pressed and the mouse is moving. Then we get the computed style of these nodes, the slider itself, which we can easily access because we passed the entity as part of the slider knob component, and the styling of the knob. Then we do some calculations. I don't gonna include them here, but think of it like this. The button is somewhere in the container. We have to figure out how much percentage it's left to the 0 and then do some calculations and some scaling. If you want to know the exact math, look at the GitHub. It's all open sourced and these slides and examples are there. But out of convenience, I'm not going to go into detail because, yeah, it's just some math. We find the value, the offset, how far the slider currently is from the left side, and we're going to add the mouse delta in relation to it and make sure it doesn't jump outside of the bounds. And finally, we're going to add the value we just calculated to the slider entity, which holds our state. And now we can trigger our special onChanged event, which does nothing by default, but we tell it here that we are going to trigger on the slider entity, the owning entity. So we just notified everybody else who uses this slider that we have changed. You may look, you may query our values and see for yourself. So, and that's exactly what we are going to do next. We are going to check if our values have changed. And you can see here, we hook the onChanged event on our new slider component, and we call another function, in this case, the update text function. And we also specify a target. Target is another special attribute in this case that can, given an ID, resolves to the entity itself. So when we query the UI target, we don't get the value here, that's here, but we get the entity that is the text. Yeah, very simple. We are going to, where are we? Oh, yeah, it's an observer, right? It's an observer in this case. So when the onChanged event is triggered on the update text, we are going to query the slider entity and read its value. And then we are going to get the text that is behind the target entity and change the text inside the text component. And thus the slider updates. And that leaves us with the final result. We have two unique sliders that update the UI at some other place. And you can now easily attach something like change the master volume, change the dialog volume, and you are in full control of the styling part that can still be updated live in the HTML part, and it will resolve without compiling again. And you can easily style your UI. that's it. That's a full example of a complicated widget. There are way more than that. And if you want to create your own or want to go deeper into it, I highly suggest checking out the plugin. I also have a widget plugin which provides some of these functions for you to have something to start off, like a multi-axis slider, text inputs, or some simple drop-downs. And yeah, with these simple API functions, you can basically create anything that any other UI has, and still hot reload the styling part. If you want to try it, just do cargo at Bevy UI, and it's already out. So feel free to try it for yourself. Yeah, that's about it for me. Thank you for listening.
Thank you, Lorenz. Awesome. I still have to get my hands on this myself, but yeah, I think it's exactly like scratching one of those itches, right? That is very hard to keep recompiling and not being able to just edit a script and take a look at the changes. So this is very appreciated. There's a bunch of questions, so let me get quickly started on those. The first one is, so it's technically not HTML, but just XML-like format, correct?
That's correct. It's not HTML, it's not XML, it's somewhere in between, but it looks like HTML. So yeah, there's a cheat sheet. Yeah, I have to mention there's also a big cheat sheet with all the values that you can set on the GitHub. So if you're interested to check out all the attributes available, as I mentioned earlier, it's just snake case, Bevy styling. But if you want to have an overview, there's a cheat sheet.
Nice. Okay. Yeah, do you manually have to add support for all possible node attributes, or is this, is it using some sort of reflection to get that? Like, for example, I guess the recent example with Bevy 15 introducing scrollable like panels and stuff, is that something that only works once you've also added support for it?
I have to add it. There's no way around. It's a custom parser, completely written from scratch. And when I want to hook up it to Bevy functionality, I have to also edit from scratch. It's not that complicated. And I just, this plugin was already available in Bevy 0.14. And when I did the 0.15 update, adding the new UI functionality was very fastly done. It's not that complicated. Just a big match statement at the end.
Yeah. Don't tell anyone. Sounds a bit like sounds a bit like Cobweb UI. Are you aware of it? And what are the differences to your crate?
It's similar. It's similar indeed. The main difference, of course, is I wanted to be very close to HTML structure so that I can use tools I already use, like Prettier for formatting, or some code syntax highlighting, or even use XML. You can also use XML, and there's also a somewhat broken autocomplete XML. I don't know how these schema files are called. There's a schema file for XML if you want to use that. And you have a little bit of autocomplete, but yeah, it's not truly compatible with XML, so a little bit broken. But
yeah, like Prettier and stuff, they will be able to format it in some sort of sensible way when you use XML for it. Yeah.
They don't.
Yeah. Does your nice UI library work on WebAssembly?
Yes, it's working on WebAssembly. It's working on mobile. It's working for every singular library or target Bevy UI supports, because there is nothing. I didn't do any custom rendering. It's just compiling the syntax, the HTML-like syntax, into normal Bevy UI. There's nothing out of the ordinary there. So every target works.
That is probably their question, because it further states that text input is somewhat tricky and but of course it doesn't really make a difference if you use Bevy UI or Bevy GUI then, because what you end up generating is the same, right? Yeah.
In my widget crate, there's an example for text input, but it's already, as it's not part of the plugin itself. The plugin itself is just the wrapper around Bevy UI with the transition and the API to hook up logic, but there are no pre-built components.
Yeah. Oh yeah, the last question is actually if you've also created an XSD schema for the XML flavor that you built there. probably format it or validate it. I mean,
Yeah, it's just the problem is XML doesn't like prefixes. So when you have something like hover, semicolon, or a double point, you will get a huge error. And everything stops working because the namespace syntax in XML is a little bit different. And I couldn't live without that. I didn't want to come up with something special that just works for XML. I'm used to the double point syntax from other front-end libraries, for example.
Gotcha. Okay, well, that's about it in terms of questions. I hope everyone in chat gives you a big hand. This is an amazing crate. It's still on my list to try out and to hopefully improve my life when it comes to building Bevy UI. So very much grateful for you building this.